please come on up. Kicks Lab Halves.
Is there another? Okay. Hi, we're Team Kicks Lab. This is our incredible team, and let's meet the people behind the lab. This is our talented team of designers, and we are supported and guided by our faculty advisors and consultant, and our two incredible external partners, ANSYS and Zellerfeld. We are developing a simulation-based shoe design game that gives students insight into how materials and design impact the shoes that they wear daily, teaching them how athletic shoes are designed and engineered through problem diagnosis, iterative failure, and data-driven decision-making.
So now we're going to dive into some of our goals. Many American teenagers find traditional STEM learning to be dry, abstract, and disconnected from their everyday lives. This is due to lack of hands-on projects, extracurricular opportunities that nurtures their agency in the learning process, which further limits sustained engagement aspiration for STEM to pursue STEM fields. So our game, Kicks Lab, solved this by transforming the abstract principles of science and technology into something relatable and fun problem-solving experience. We aim to foster their agency by a simulation-based learning that empowers students to design, test, and see their direct impact on a shoe. Our target audience is 13 to 18-year-old youth, teenagers who might not see themselves as STEM kids, but they love to tinker, build, and solve problems in their own way. We envision our game to be played in after-school programs where teachers and students can interact. And here are our educational goals. Before playing, the students can be hesitant in making and experimenting, being passive learner in school. However, after playing our game, their confidence can be boosted and be more creative problem solver and be more active in experimenting to find solutions. Also, they might have limited sense of agency in problem solving and see science and engineering as a separate, theoretical, or irrelevant to everyday object. But however, after playing, we want to enhance their sense of agency and creative problem solving, as well as higher understanding of structure, property, performance relationships. At this point, many of you might be wondering, why does it have to be a shoe then? The shoe acts as a micro lab on foot, making STEM concepts feel real and applicable to everyday life. A shoe is a perfect medium for learning STEM because kids wear shoes every day and can intuitively understand their functions and failures. This familiarity makes abstract scientific concepts more tangible and easy to grasp. So we established 3 major game pillars that ties our game into one core concept. First, the player analyzes and diagnoses a problem in a shoe that customer brings. The player must observe the existing shoe and analyze the data, forming hypotheses about the cause of the problem and possible ways to solve them. Second, they go in a loop of iterative testing. The player can actively test their hypothesis by running 5 different kinds of tests, and the game allows for a low-stakes environment where the failure is a necessary step toward success. Third, the players interpret visual and numerical data to figure out actionable decisions to solve problems. They learn data literacy, and this skill, translating raw data into an actionable decision, is far more valuable than recalling or defining a definition. By repeatedly engaging in this cycle, kids learn critical thinking, problem solving, and resilience. They grasp that failure is not the end, but a stepping stone to success.
Okay, I will talk about our gameplay. So here, the player works at the Kicks Lab, and we help shoe companies to diagnose and improve their products. This is our flow chart. A customer arrives with some requirements, and this is Kicks Lab. We have prototype lab where the player can change the materials and then do some tests on the shoe. If we fail some tests, we will tell the players how many you have passed, and we change it again, and finally you pass all tests and submit the shoe. Let's go through an example quickly. So if we want to make a shoe for a fisherman, so I was thinking what a fisherman want. Maybe water resistance. So I will choose different materials for different parts of the shoe. And then we will perform 5 tests. So here, maybe a slip test. There will be some ANSYS real-life simulation here. And finally, I get a grip. Okay, I have enough water resistance, but the grip is not enough. Maybe that's too slippery to step on a rock in the river. So I change the material again, to test again, and finally I satisfy my customer. So how many times we want the players to play? So if you play a game 1 time, maybe he just get exposed. 2 times, you start to build interest. And maybe 10 times or more, you are proficient and master. So we want the players to play around 5 to 10 times. You have interest, and you can really learn something. And finally, we have a notebook of the materials. If you submit correctly, like 3 times, you will unlock the exact data, the numbers. That aligns to our goal that we want the player to think about the materials, properties, and do some data analysis.
Given our framework, this is how the team has approached generating content. The bulk of our content comes in the form of the design space we open up to our players. Specifically, what shoes are they able to make, what options do they have, and how are they presented? We've identified some key features that this design space needs to possess. It needs to be organized. It needs to be organized. It needs to authentically reflect how materials and structures behave in real life. Wait. That's right. Players need to be able to come up with a variety of different designs. And finally, the design space needs to be within scope for our team to produce, as well as for ANSYS to run simulated tests on. That's right. Our clients are central to our process of generating content. ANSYS is an engineering simulation software company. Their involvement in our process is what gives us confidence to say that we can authentically represent not only the scientific properties of materials and structures, but also the real-life design and engineering process. Zellerfeld is a pioneer in 3D printed footwear production and distribution. And although we don't aim to exclusively represent design considerations specific to 3D printed footwear, their expertise come into our pipeline in the form of their design templates and guidelines. And so here's how our pipeline works. We take their templates and guidelines, we build 3D models that can conceivably be 3D printed into real shoes. We hand those models off to ANSYS along with a list of materials as well as tests, and then we take that simulated test data, package it, and present it to our players. Here are some photos from our visit to ANSYS where they ran a live demo, where they did a live demo of running simulated tests on the model we provided. With our pipeline roughly laid out, our team began looking at lots of shoes for meaningful variations. We looked at how different structures and materials can be employed to achieve different functions. Take the example of this court shoe. A firmer upper material combined with a straight up and down sole offers lateral support, whereas in the case of the running shoe, the reduced need for lateral support allows the shoe to use a softer and more breathable upper material, as well as an accentuated rocker bottom shape. The point is, there's usually a trade-off between the different options, and we want to be able to lay down a set of structures and materials that come together to become functionally different shoes. The other part of the package that we're handing off to ANSYS are the different tests that we want simulated on our shoes. So a pair of real shoes usually goes through 2 different types of tests, mechanical and biomechanical. The former usually involves a simpler setup that measures specific physical properties, whereas the latter usually involves human testers and usually gives a more holistic evaluation. Early on in our communications with ANSYS, we determined that biomechanical tests would involve too many variables to be simulated efficiently, and so we would gear our content towards mechanical tests. And finally, as we look at all the materials and structures and tests, we also think about how we'll organize it and present it to the players. This is a way to break down a shoe that was given to us at the beginning of the semester from Charles. And as we verify and edit, we eventually arrive at our current design and testing variable breakdown. This helps us keep track of how we're going to organize the game, as well as it will be helpful in our future communications with ANSYS in terms of our concrete workload. On an extra note, we arrived at our visual identity by looking at sports shoe advertisement that would appeal to our target audience. And specifically, we're looking at advertisement imagery that sort of emphasizes technological innovation and involve a sense of playfulness.
Next, we move on to user study. Early on in our project, we identified barriers to STEM engagement as a lack of relatability and access. Since then, we've spoke to our target audience in real life and found much of what it says aligns with our research. Kids told us subjects like physics and math can be boring sometimes when not connected to real life. But science is cool when it's applied and observable, like when working with microscopes and plants and animal cells. Subsequently, we also spoke with STEM leaders with extensive experience in STEM learning and youth engagement. With our chat, we extracted some invaluable design strategies. Starting the game with a problem that elicits empathy from youth is a very strong approach. Creating different entry points to accommodate youth with different levels of prior knowledge is also helpful. With our previously established game pillars, we went into prototyping and playtesting. From our playtests, we identified two playstyle archetypes. The analyzer is somebody who carefully reads the labels of the materials and try to deduce each material's properties. Cross-check choices against own experiences with shoes. They tested only once because they had already formed a hypothesis before making the selections. The experimenter, on the other hand, skipped reading material descriptions, jumped straight to testing by pressing buttons, matched stats via trial and error, iterating multiple times until bars are aligned with the goals. They focus a lot more on numbers and bars and not the qualitative material properties. Hence, to take away from this, through our playtest insights, we identified the behaviors that we want to encourage in our gameplay and the behaviors we want to reduce. We want to encourage informed decision-making with formed hypotheses or information gained through trial and error, and also discourage player brute forcing or blindly matching stats. Since our game is designed to be played in after-school programs, educators play a role in providing hints during gameplay, clarifying materials, and also to facilitate post-game discussions. Talk about the struggles and successes in the designs.
So now let's take a look at our strategy for the remainder of the semester. We plan to run playtests in a few different locations, starting with scheduling visits with Life STEAM Male Academy, City Charter High School, and any other educational organizations that we can find to partner with, as well as attending playtest nights at Hunt Library. We will be measuring success based off of feedback from observing the playtests and post-play interviews, which will help us refine our gameplay. We recognize the potential for challenges to arise when working with multiple stakeholders and experts, and we plan to maintain clear and consistent communication during production. This is essential to keep everyone aligned and satisfied while maintaining the project's core direction. Additionally, the framework has undergone extensive research and redesign to produce the most reliable estimates of game outcomes before being confirmed with the ANSYS data. This will be further refined through extensive playtesting and as we receive the results of the ANSYS data. Here's our plan for the rest of the semester and our timeline for completing it. And then we plan to deliver a fully playable game for PC and tablet where players can experiment, test, fail, refine, and iterate in a low-pressure environment using ANSYS's data and simulations. Success to us would be giving players access and insight into design and engineering through familiarity that they can relate to with their own shoes, and helping them see how scientific choices can have real-world impacts. Thank you.
So I have a question. You emphasized failure a lot, that it's an important part of the learning process, and you want to encourage trial and error. Can you talk a bit about how your game might try to create failure in a natural way so that the students actually learn that lesson and not make it too easy just to get to the right answer?
Well, a couple of opportunities, right? First of all, we thought about coming up with ridiculous customer requests, right? I want a hiking boot, but then I have a super smooth outsole. So that's an opportunity. Another opportunity is we can include some ridiculous options for materials and structures. Anything to add?
We played around with different types of testing as well, and as we go through production, we'll continue to refine and see how we're going to manage the gameplay loop in that area. We've played with trying to make it feel more natural through like kind of going off of what Sky was saying, like kind of incredulous like tests, like if you had to design shoes for walking on the moon. And also trying to figure out how we can really engage with our audience as well and make it like a safe place to fail and iterate.
And to add to that, I think for our game, this spreadsheet actually shows the variation, something very simple like 4 components to a shoe and 3 materials on each component can generate. So the spreadsheet here shows that with these variations, there would be 96 tests, and so there are 32 structural variables that can generate from these 4 components and 3 materials on each shoe. So we do believe that the higher level of variability would generate many possible outcomes so that it would be harder for kids to just brute force through it.
So you mentioned the sort of like the win conditions for you as a team. Can you explain or shed light on the win conditions for your clients? So what is ANSYS excited about this, and same with Zellerfeld?
So when we visited ANSYS in their company, they told us that there are 3 types of data that they can deliver to us. One would be numerical data, and the other one would be a GLB file or an MP4 file. So as we worked along with them, we tried our best to see what is the best way to present the mindset of somebody who is working to create a simulated test, and to be able to convey that to an audience that would not otherwise have access to this knowledge. And through that, ANSYS expects us to be able to create an abstraction of this process of understanding what forces are acting on this particular test and how do we extract meaningful data from it as our final deliverable.
And I think to add to that, the fact that we're building this product that bridges what they have with an audience that they previously don't usually deal with, right, could be potentially exciting for them because, you know, in colloquial terms, they usually run tests on turbines and engines. And I think the fact that we're connecting them with a younger audience, with an educational purpose, could be exciting for them.
Yeah, and kind of going off of what Sky was saying as well, they do have like university level like types of kind of like programs where people can start to learn how to do it, but nothing for our target audience, and it has the ability to target youth with it when they're at the point in their life where they're starting to think about what their future might look like and where they can what they might major in.
Sort of building on that, I'm kind of curious how you are thinking about the balance between sort of representing the reality of, say, ANSYS simulation and being approachable to your audience.
That's definitely something that we've been working on, and it's probably been one of our biggest challenges so far, is trying to find the engagement aspect and like the kind of fun out of it with the educational and like deep learning types of concepts that we want to instill. And so I'd say that we've interviewed a few different like people within that age range, and we're going to continue to refine through like play testing and try and take away from there. And we've also been talking with some like subject matter experts within education as well who help educate and facilitate, like would be the type of facilitator we would want for this type of project.
I think Derek should have.
Yeah. Oh yeah. Testing. Hello. We are the Intergalactic Buccaneers. Welcome to our Halves presentation. Here's our team. We got Ifan, Emily, Junior, Nina, and myself, Derek. Our instructors are Ruth and Dave, and our subject matter expert is Steph Harbuck. She's been advising us on LBE design. So, what are we all about as a team? Well, we're really about the space bridge. I'm sure most of you have seen it and heard of it. Our main goal, we really just want to use this space bridge to make awesome experiences. The space bridge is this really interesting opportunity here at the ETC. You can kind of think of it in the same vein as the Cavern or the Jam-A-Drum, which I'm sure you're all familiar with as well. Like those two platforms, it's something that was built and deployed here in the ETC building and presents a really interesting opportunity for design that's pretty unique to this space. You can't really find it many other places, and yeah, it's just this cool thing. So really, concretely, what we want to do is make an experience for the Space Bridge with the aim of deploying it during ETC's Fall Festival 2025. But how do we actually do that is the question, because the Space Bridge is the only unique platform here at the ETC that students like us actually can't currently develop and deploy to. And understanding why that was the major focus of the first half of our project. And what we really found is that it came down to two major factors: hardware and design. On the hardware side, we found that there was some updates that needed to be made to the hardware of the Space Bridge in order to make it compatible with the pipelines that students like us often use to develop for projects today. And on the design side, I'm sure you've all seen the Space Bridge. It's this large, complicated machine. It's in a pretty interesting location. It's got 36 buttons alone, not to mention all the trackballs and joysticks. Understanding its affordances and constraints was something that our team was going to have to do before we actually made something refined. So, knowing that, what we needed to do was develop the Space Bridge into a platform that our team could actually use to develop experiences that we were interested in. And then we also needed to just learn about LBE design using the Space Bridge as our sort of home base, understand what it could do, what it was a little weaker at, and just get a sense of what was possible with it. So specifically our deliverables, what we're aiming to do, we want to document how you actually design and deploy for the Space Bridge as it will stand at the end of our project semester. And we want to develop a concrete experience that's geared towards deployment in a context like Fall Festival. So with that in mind.
So, what have we been doing in the past few weeks to achieve our goals? Before getting to technical details, we want to give our greatest special thanks to the tech team, Steve, David, Brian, and John. All those cannot be achieved without them. So here's an overview of the old structure of the Space Bridge. So let's take one side as an example, zoom in, and see what made it so complicated. So the old Space Bridge used 8 PCs to drive its operation. There are 6 stations. Each of them has 1 PC to control all the fidget buttons and 2 speakers. And then there's an additional display box to coordinate all the displays of the 6 screens together. And then there's another brain box to control additional audio and lights. So since all those PCs are working independently, they have to communicate through net cables to guarantee synchronization. Therefore, the wiring is complicated. It is hard to set up and even harder to maintain. At the software side, if the developer wants to deploy a software, they have to do it individually for all 6 PCs. And the operating system was outdated at that time as well. To get the platform easier for future exploration. We simplify the structure of the bridge. Take one side as an example. We reduce 3 PCs to 1 to control all the fidget buttons, displays, and speakers. You can see that we only have to worry about the communication between the 2 PCs as a result. And in addition, we also built a emulator in our project room that we call the mirror bridge. It reflects the functionality of one side of the actual space bridge. Before deployment, we run tests on it.
So now we have a standard 3-step pipeline in a stable production environment for us to start developing. But what does it mean to start designing on the bridge? Well, it really comes down to 3 design constraints. First, the specs of the bridge. The bridge's control layout is unique to the ETC, and whatever we make for it has to be able to fit within the existing layout. This does mean that whatever we make has the opportunity to be very interesting because it's one of a kind. The second constraint is the audience. The bridge is seen by faculty, student, staffs, tour groups, and guests of the ETC, and it could serve a different purpose for each of these groups. And the third is the location. The bridge is currently on the 5th floor in a high traffic area outside of the elevators, and it serves as a hallway between the 2 connections of the 5th floor. Whatever we make for this cannot disrupt that area, and so with these constraints in mind, we've made 3 prototypes that combine different aspects of these in order to test the possible combinations when designing for the bridge.
So our first prototype is based on a sci-fi scene. So we have 3 players. Each player take on a distinct role that operating separate stations. So we have an engineer, a captain, and a navigator. So one of the players is gonna focusing on navigation, and while the other one is gonna focusing on shooting asteroids, and the last one is gonna fixing the broken engine.
So this was our first attempt at designing an asymmetrical experience on the bridge, and we encountered some initial technical problems getting onto the space bridge that we have to resolve. We found that not each panel was as easy to design a fun experience for. For example, the joystick panel was quite easy, while the trackball panel is more like open questions. And of course, the sound in the hallway isn't perfect. The overlap between the consoles and from outside the hallway makes the communication a bit more difficult at times. So moving on to our second prototypes, we went on the different directions and created this frictional flow. In this Korean-themed clicker game, the players can participate casually in a simple, short but repeatable gameplay loop. Everyone walking by could press a button to earn bubbles and use the bubbles to purchase upgrades in the shops, feed the fish, decorate the tank, and make the click more effective.
So for this experience, we want to make the whole game just simple, quick, and easily accessible. So sometimes people would just come around, play it for a few times, but wouldn't take most of their time. So during the playtesting, we found that people actually can't stop pressing the buttons. So the feeling of pressing a real button is completely different than just pressing something on your keyboard. And our third prototype is Midnight Security. So in this game, people are gonna become security guards supporting multiple camera feeds. So they have to switch cameras, find strange events, and survive the night by catching out-of-place scenes in this Spot the Difference game.
Inspired by some of the lessons that we learned from our first prototype, where we ran into difficulties trying to utilize every single element of the space bridge to create a fun experience, we instead narrowed the gameplay interface primarily down to the center screens. For the focus of this experience is on observation and the idea of allowing spectators who aren't in direct controls still be able to participate in the gameplay. When designing this experience, we learned that not every screen need equal gameplay importance. Some of the displays could be there functions as a focal point to guide attentions, while others just be there simply to create atmosphere.
So at the end of our prototype cycle, we have these 3 quick experiments that we made, and looking back at the design, we kind of have three broad lessons that we think sort of tie these together. Firstly, and probably most importantly, we found that when it came to designing experiences on the Space Bridge, using every single control in a unique way often had diminishing returns. That like, if you're going to make an experience for the Space Bridge, it's better to understand what you actually wanted to do and figure out which controls are actually necessary. And for the controls that aren't as necessary, find either duplicate functionalities for them to hold or just ignore them entirely. Because very rarely do players actually try to press every single control and see what they do. And it often made it more confusing if we tried to make everything unique. We also found that people tend to find the click of an analog button far, far more satisfying than the click of a keyboard or a mouse in a way that is pretty difficult to describe. In playtesting the clicker game in particular, having someone come up to my computer and click the mouse and see a number go up was questionable. But having someone literally come up to a box with an arcade button and click the button, I didn't have to say anything. They just couldn't pull them away. So, and then finally, we found that the Space Bridge itself kind of speaks for itself in a sense, in that if we want to get people attracted to our experiences, putting something that was fun and interesting visually on the screen was basically all we had to do to get over that initial barrier of entry and get people to even be interested in seeing what was going on. So, what's next? Well, like we said at the beginning, we want to make awesome things for the Space Bridge. And now, well, the Space Bridge is platform ready. We can develop and deploy to the Space Bridge and have our experiences live up on the 5th floor. In fact, you might have seen if you passed by, we currently have a bit of a screensaver showing off some of our prototypes up on the 5th floor right now. Our team also, through the prototyping cycle, has gained some experience. We now have a sense of what's actually possible on the Space Bridge, what's easy, what doesn't work. Obviously, there's an infinite amount of experience one can gain, but we now have a sense of what's actually possible up on the 5th floor. So what's next? Well, our goal, we still want to apply what we've learned about designing for the Space Bridge to craft a refined experience with the aim of deploying our work live to the Space Bridge for the ETC's Fall Festival 2025. So taking a look at what Fall Festival actually means, we've explored a bunch of variable context through our prototypes, but for Fall Festival, what's really important for the experience comes down to a handful of things. Mainly, on a technical level, throughput. Obviously, Fall Festival is one of the most highly trafficked events here at the ETC, so getting people through the experience, quickly onboarded, moving through so we don't clog up the hallways in probably the most busy space of all of festival, it's pretty important. Another thing to consider, the mixed age demographic of festival. You'll have students of ETCers ranging up to older alumni, and everyone in between coming by and seeing the Space Console. So thinking about how to design an experience that can have some appeal to as many of those demographics as we can is pretty important. And of course, thinking about what the actual purpose of festival is. Of course, it's celebrating the creativity of the work that goes on here at the ETC. So something our team is considering is how we could make an experience that both fits in that context and sort of feels also like a celebration of the ETC as this sort of creative center. So,
here's an overview of our actual timeline. So our first major goalpost will be playtest day, where like our past prototypes, we plan to create something playable and get feedback and iterate on the next few weeks and develop our design further. We plan to be pretty much done for softs and just allowing room for faculty input before we submit to festival jury. And then in the last few weeks, we plan to compile all of our documentation about how to develop for the Space Bridge, and then hopefully enjoy festival. Thank you all for watching, and we are now open for questions.
Can you talk about the approach? You know, the bridge has such a strong physical theming in real life presence. Fish don't have anything maybe to do with that. How do you navigate that?
Okay, so yeah, the sci-fi theming of the Space Bridge is honestly, surprisingly of all the things, one of the biggest challenges, because you want to make a variety of experiences, but the physical shell of the thing is so sci-fi. And honestly, the way our team has been approaching it has been by kind of just accepting that not every experience we're going to make, especially if it's testing an unusual interaction, is going to fit neatly into the screens. And there's just some distance that's going to have to be overcome if we put, say, like a horror game or an aquarium game up on the Space Bridge. It's just going to have to be an aquarium that's framed inside of a Space Bridge.
The blue light actually helps, yeah.
And another thing is hopefully designing for a festival, I think one of our plans is to take that as a design constraint and to hopefully build something that really fits in the space and represents the space in the ETC.
Yeah, it's kind of about accepting the degree to which you're okay with the interactor having to deal with that dissonance.
So is the theming, changing the theming is out of scope?
Yeah, we are not going to change the physical components of the shell of the space bridge.
Okay, I have a real question and a fun question. My real question is, if you went down from 3 PCs to 1, that seems like a very logical step. So I'm curious if there is a con and why that wasn't the initial design.
Well, because the initial space bridge was, someone correct me if I'm wrong, but I believe that the space bridge was originally a student project made in 2006 or 2007. So initially on a technical level, there's so many fidget inputs and USBs going into one PC that I believe when the space bridge was first developed, there actually was some technical limitations on what was possible. But now in 2025, it is something that we are able to do. So looking at upgrading that was something we pursued.
So you switched the PC. It's not the same. Okay, that
they are
makes
different
a lot
PCs now. If you
That
actually go
makes-
back behind the space bridge, you can see there is a rack which has a lot more space on it now.
Okay, cool. And then my fun question is, it sounds like you have some good findings and some good constraints. What are your ideas for what to build for Fall Fest?
Oh, well, we have a lot of, we're sort of in the ambitious ideas phase right now, but I can share one. One thing that we thought might be interesting is, because one of the interesting constraints of Fall Festival that we didn't mention is it's time bounded. It's a 4-hour block, pretty specifically, but that's also kind of a strength. We could design an experience that is designed to be real time over 4 hours. Take, for example, the Midnight Security, where you're trying, the way this game works, to get more specific, it's like a simulated day. And over that day, things change in this world as you switch through security camera views, and you have to make sure to catch those differences. One of our thoughts was, if we know that Fall Festival is going to be 4 hours, and we design an experience like this, we could choreograph all 4 of those hours and have these changes and events happen in real time over the course of Fall Festival. So that's one of our ideas, but it's a bit ambitious.
It's always a challenge in situations like this for you to create the situations so that people know they may play, they have permission. How are you going to address that?
Yes, well, there's of course I can answer this. There's the traditional game things, like you can think of traditional arcade cabinets. You know, you have your screen, it's maybe playing a demo of the game, but you have text on the bottom blinking, like press any button to start. But there's also, on another level, the positioning of the space bridge kind of works in our favor here, where people are essentially forced to see it, so they are going to see the space bridge. And when one of our earlier points that the space bridge kind of sells itself is that if there is something that seems alive and active on the screen, and this is a more specific, if the buttons are flashing and blinking and look on, people are just drawn, people will come up and just press the buttons. So a lot of it's just making the thing look dynamic, look like it's moving, and then when people come out of the elevator, it just seems like something that calls to them. So yeah, that's really the main approach, just make it look alive.
Thank you.
Okay, let me just test if our video plays. And, okay. Just testing. Okay, it plays. Perfect. So now how to start the presentation? Oh, here to start the presentation. Okay, perfect. Okay, so yeah, coming in. Welcome to our half presentation, and we're Team Trinity. Our goal is to make an asymmetrical collaboration game for 3 players across 3 different platforms: VR, PC, and mobile. And our goal is to have 3 Gen Z players, everybody here, yeah, to enjoy a good time, connect with each other locally, inside of a room like ETC Game Room. And our definition of success is that we want players to have significance, connection, and fun. So to do that, we want players to have unique and comfortable gameplay on their platform, and they have influence in the game, and as a result, they're synchronized with each other to have connection. Let's jump forward to our prototype. Okay, that's me. I'm the cat with the jet engine on my back. Or you? I'm the jet engine. I need to get through these obstacles. I can help you down to do that. Maybe I can break it with my fire. Cat, can you fix it directly? Sure, I get it. Oh no. I'll push you in the opposite direction of the fire. Okay, don't worry, that's a good idea. Okay, so this time around, guys, first jump across the first gap. And move. Gambler, could you lower the top, please? Sure. Now it's my time. Push up. I can't jump over this. I can't use my arm. Thanks for all us to overcome this. Ready? Push up.
Yeah, so that's our current prototype. Yeah? Yeah, and special thanks to Anthony who helped us film this video. Yes.
Okay, and so that's part. So to sum up our gameplay, we're making a game where each player has a different role and different abilities based on their platforms, and they collaborate to solve problems. And that's how we define asymmetrical collaboration game. Now let's jump into tech.
Okay, I'll briefly walk through the technical side of our project. So here's a diagram of how we're set up our devices. So imagine like at the game room setting, the PC will be connected to a big screen, which will be also shared with the mobile player, and VR player will use their own VR headset display. So this way, we want the players to have different access to different amount of information, so we can encourage them to collaborate through talking. And as we mentioned earlier, we are making a real-time multiplayer cross-platform experience. So that doesn't simply mean we are mirroring the same gameplay over the 3 devices. But our goal is to utilize the different input actions, different input methods of 3 devices to give players entirely different game experiences. So for VR player, we are using Meta SDK with hand tracking and 3D view. So the player can physically interact with the environment. And for PC player, we are using an Xbox controller, which enables the player to perform precise movement and quick actions. And for mobile player, we'll be relying on the gyroscope sensor and the touch input. So they can perform actions like shaking or rotating the phone, so it feels naturally mapped to the same actions in the game. And since our game is cross-platform, we are doing local local area networking. So for PC and mobile, for PC and mobile, we'll be transit data through local networking, and for VR, it will be perform more like extension display of the PC, and they share the same network client. In this way, we can reduce the network latency because we don't need to synchronize the entire 3D scene.
And now we are moving on to the visual designs of our project. So first, I'm going to start with our crow of the whole experience. So our crow is a jetpack and a machine giant who are leading a cat to cross the barriers, to overcoming the obstacles, and finally reach the final destination to become their god. In a creatureless techno-surrealism world. So what does a techno-surrealism looks like? Based on our understanding, we think this is what a techno-surrealism should be looks like. So this image is an image from, we think it's the most representative image from our mood board. It was created by the artist that we like the best. And we think this one represents the best to our art style. And based on this style, we have made a couple of assets that can be replaced our playable game objects. So from the left to the right, which are the rotatable platform, the moving gate, and the horizontal platform. And we also have our cat avatar and the jetpack on the cat's back, and also an interface of our mobile device.
So to enhance our players' experience, we make our art design decisions based on our crow and also this logic, from avatars to actions and to influences. We assign each of our players with their own avatars, the jet engine, the cat, and the giant, and we let them see each other's avatars in the game world to create a more immersive experience. And for the interactions, we emphasize the influence that each actions cause to the game world to make players feel that their actions are important. For the mobile player, when they select the direction button on the control panel, the energy liquid will fill up as CD, and they can shake the mobile phone to start the fire. And through these actions, the mobile player will control the model animation on the jet engine to change the fire direction, and also start the fire VFX to push, uplift the cat avatar, and also attack. And for our VR player, by grabbing and spinning the objects, they can activate the shaders on the objects and also power up and move the structures to move obstacles. And for our controller player, the action and influence are straightforward. They will control the basic movement animation of the cat avatar using the controller, and also affect the trail effect on the jet engine to show their moving paths. And then let's move on to our playtest and iteration.
For the first 6 weeks, we made 2 playable prototypes and playtest the first one by week 4. And based on the feedback we received, we created the second prototype to playtest on week 6. To briefly catch up our first prototype, we spent the first 3 weeks making a battleship game to test the multi-platform pipeline, and also to give a brief sense of what the collaboration should look like. In this prototype, the controller player drives the battleship, the VR player controls the weapons, and the mobile player was in charge of the radar. This game has fun moments, but it also has serious problems. So we unfortunately didn't continue with this prototype, but we did learn a lot of lessons. And here's the key insights we gained. We realized that mobile players are unsatisfied with just providing information, but would rather have more feedbacks to their actions. And we realized that PC players feel restricted when their decision-making constantly needs information from the 2 other players. And VR player complain most about the motion sickness due to the unnatural movements, which we definitely want to avoid in the next design. Based on the insights from previous prototypes, we designed our second game. We make sure that all actions from the mobile player are visible and influential to the game.
And we also designed VR to be playable while sitting still. What also pops up during the process is the trade-off between dependency and agency. So our team solution was to strike a dynamic balance, giving each player the chances to shine and carry in different stages. We want to approach this particularly through level design.
The experience of this prototype will be primarily delivered through levels. We will use a very simple example to get to a high ground to explain how our level design makes sure each player is significant and they are connected, they have dependency to others. And these two, the connection and the significance can coexist. The image on the left is the VR player's view in their headset, while the image on the right is the PC player and the mobile player's view displayed on the PC screen. They will all stay in one place, in one scene, and solve this challenge together. Significance is carried through actions that are unique to each platform. In this example, the VR player will first need to grab and rotate the wheel, lifting the cat upward, and the PC player would need to input a jump towards the high ground. But that is not enough. The mobile player will need to shake their phone when the cat is in midair, performing a super jump to finally reach the high ground. If the correct input of any player is missing, they won't overcome this challenge. This can make sure each player is critical to the team. But how they figure out this is the correct solution, that is where communication comes in. To the VR player's view, they have the best view of the level. They need to first share their info they get to their teammates for the team to figure out how to solve this challenge. When they're actually solving it, the PC player needs to call out a joint action because they have the control of the cat. So they need to report what they are going to do for the PC player, for the mobile player and the VR player to think their actions. The mobile player will need to report whether their ability is ready to go, and they also need to sync the actions correctly with the PC player's pace. The success of any level, any challenge is important to the success of overcoming any challenge requires everyone to be deeply connected with the team as a whole. With these design principles in mind, we can create more levels and more complex levels in which their actions and their info need to share may change, but the principles stay still. And thus, we can make sure our levels and our game can align with our project goals perfectly.
Now let's talk about what we will do next. So first, we'll keep iterating our game. A lot of people in this room have already played our game. So we want to iterate from our last playtest is that we want to make mobile interactions more intuitive. And we want to utilize more of the 3D space interactions for VR player. So they are no longer only dragging things on one plane, but also in the 3D space. And for PC player, we're going to give them more challenges to do. And finally, since this is a game for 3 players to connect with each other, we want to embed more social interactions, like saying hi to each other in our game. And our final deliverable will be one game that signifies fun, significance, and connection as a result. I see a lot of first-year students coming to our presentation today. We have playtests every Friday from 3 to 5 p.m. at ETC Game Room. Please come to our playtest, and your feedback will be very critical to our iteration. We have playtests this Friday. And our production schedule after the half will be, we will be having a draft of our final full experience by week 9. And after that, we'll spend at least 3 iterations before week 13. And by week 14, we'll have a beautiful game that's ready for QA and polishing. And we'll present it on the final week. So it takes 3 to play our game, but it takes 6 to make this game. I'm Jerry. I'm the producer and programmer of the team.
I'm Helen, the 3D and technical artist.
I'm Max, the 3D and concept artist of the team.
I'm Vector, level designer.
I'm Sharon, the VFX artist and sound designer.
I'm Ifan, the programmer of the team.
Also, special thanks to our instructors, Brenda and Scott, who provide a lot of useful insights on our development. And so, to sum up, it's a collaboration game across PC, VR, and mobile platform. Thank you all for listening. Yeah. And time for Q&A.
Forgive me if I missed it. Is it the game dependent on the 3 separate platforms, or can you have 2 and 1? You know what I'm asking?
The game is dependent on 3 separate platforms. That's one of our design premises. Yes. Yeah. So we do have a reason for why we need the 3 platforms, because we want to provide 3 different experiences for 3 different players. And that's why it takes 3, not 1 and 2 to play this game. Yeah.
Thanks. Question about your art style choices. I really like the techno surrealism that you guys are going for. Can you talk about how you're going to use that to influence gameplay as well? I think is there a way to use that to pass information to the players about what they should be doing and just deepen the experience? So if you can talk about that, that'd be really good. Thanks.
Yeah, exactly. Can we go back to the RSAT page?
Okay.
Asset page.
Okay.
Yeah,
I'm trying hard. Okay. It's already.
All right. Actually, we have already thinking about this. Yeah. So actually, from when we are analyzing the mood board and these reference images, we found that in the techno surrealism, they are using the red, blue, and yellow. These three base colors a lot. And we also found that we can use these colors to make some guidance for the players. So actually, can you pass me that? So actually, we have already using, so what we are thinking about currently is we are going to use red to guide the players. Like everything that the players should go on like this platform, they will have red elements, like red things on it. So like, for example, this horizontal platform, you can clearly see there are 2 red lines on the side. And also right here, we also have red because these are the places that cat should go on. But on the rotatable circle itself, there's no red, which means the cat cannot go on there. And the other thing is that we are thinking using blue to guide the players that the VR or the mobile player should make some actions in this part using blue. So that's why all of these 3 game objects, they are containing blue, because these are all need the VR players to interact. So this is how we are thinking about using blue. And for the yellow actually is more like the decorational color, so it will appear like everywhere. But for now, we only have 4 colors, like including the black. So, but we think that these 4 colors might not enough. So in the future, we may let the white or some other colors to come in. Yeah. So this is what we think about how to make the art style to affect the gameplay, just by using the colors to make some guidance or some other thing. Yeah.
Yeah. On top of that, because this art style is very bold and futuristic, it can support any bold and futuristic gameplay we design. So we can be creative. Yeah.
Just quickly, is this couch co-op only, or are you talking about networked co-op as well?
We imagine it will be in a living room setting like the game room, so it will be offline.
Yes, and we do this because local connection is important. It's very fun.
I agree. So I was wondering about your idea to put some in-game reactions and things that you really don't need because the players are there in the room together. What are your thoughts about that?
There's only one thing about that is because VR player cannot see the 2 other players. They can only see the screen. So its own headset. So maybe if we can design some interactions so like VR player can see better what the cat is doing, or the cat can see what VR player is doing in the game, that would be good. So that's how we might design the interpersonal interaction. Yeah. Okay. Thank you.
Thank you.
Please come to our playtest on Friday.
Hello.
Hi everyone, we're Tacit. Our instructors are Vivian and Heather, and our consultant is Drew. Our goal is to create a coherent VR experience that uses emotional moments shaped by haptic glove sensations and audio and visual context, explored and playtested through discovered through rapid prototyping and playtesting. As this purpose of the project is the exploration accumulating to the design insights, our final experience will be a demonstration of those insights we've gathered over the rapid prototyping and playtesting of the haptic pattern and context design. Therefore, the final artifact of the project is not only the experience, but also the documentation of our initial exploration phase and the design principles that we've gained. At this point at Halves, with the 3 rounds of prototyping and playtesting done, we feel that we are at a point where we have gathered sufficient data that we can use as elements to build up the final experience that with the emotional impact that we are aiming for. Since working with novel technology prompted us to do really careful research, over the summer and at the beginning of the semester, we've dove into sources including perception of touch from the psychology point of view, HCI research papers on applications of categorizing haptics and emotional design, as well as case studies with relevant experiences such as haunted houses, 4D movies, and games with structures similar to the one that we want for our final experience to have. Out of all of these, the most important takeaway was that we finally pinned down the most basic parameters that we eventually use as language to communicate with each other when designing the haptic patterns. These choices were informed by the research on sensitivity differences of haptic perception and the emotional responses for different haptic patterns. This helped us categorize patterns within multiple spectrums so that our exploration onwards is sculpted and well-defined. Aside from secondary research, to focus on the exploration of the design, we decided to use the B-Haptics gloves for its comprehensive developer support. However, its capabilities is constrained to only vibrations. So specifically, it provides 6 vibrotactile feedback on each hand, 5 on the fingertips, and 1 at the back of the wrist. And then the B-Haptics website on the, okay. And this means that we aren't able to provide force feedback or temperature. However, the B-Haptics website provides with us a designer interface where we can fine-tune the parameters that we have researched, such as intensity, frequency, patterns, and waveform that we can customize. And that allowed us to design still granular enough patterns beyond the simple vibrations.
So before we receive the gloves, we design an architecture that allows us to quickly switch from the controllers to the gloves.
Because we had done all this, we were doing all this research and prototyping before the semester started during the summer, we also generated a bunch of ideas for things that we could potentially do with the gloves, different patterns and contexts. But
while we can do anything we want to do, we can't do everything. So from all of these ideas, we narrowed it down to around 3 ideas that we wanted to develop into our initial prototypes for this semester. These prototypes would serve not only our goal of testing the emotional capacity of the gloves, but also just their physical capacity, because by week 2, they had just arrived.
Building on the architecture, we developed several exploratory prototypes. So that allows us to test the capability of the gloves, such as in the elastic band prototype, we try to create a haptic that can represent resistance. And we also ran an A/B test in our rain prototype on the context to see if it has an emotional impact. And lastly, we developed several ways to try to represent the abstract interactions, such as telekinesis.
Yeah, so after making those prototypes, we went to Hunt Library and we did our first round of playtesting, and what we found was pretty interesting. So one thing that we learned from this is that in the rope prototype specifically, people were able to do a lot of agency things with the rope. They were able to pull it, they were able to stretch it, they were able to snap it back. But one thing that we found is that just one haptic pattern wasn't enough, because with all that agency, people thought that there would also be interactivity with that haptic pattern. And we also figured out that in the rain prototype, since all of the sensors are on the bottom fingertips of your hand as well as the wrist, people can do this and it would feel kind of nice, but they wouldn't be able to feel anything in their palm. And if they reverse their hand, they would feel raindrops on the bottom of their finger, which is really not great. So we take this into consideration for our final designs.
So after quarters, based on all the suggestions and feedback we had, we felt like we had the need to test haptic patterns without context. So we decided to come up with a new list of haptic patterns by themselves by mixing the parameters we have found during our research, and then narrow down the list to 15 patterns.
So we can't do the same virtual reality test if we just want to do nothing but patterns. So what we did is that we played a bunch of patterns on the hand, and then we prompted the testers to touch different photos, what they think it was most likely in that scenario. And what we found through this phase 2 of testing is that very simple interactions like poking and pinching is very intuitive, and people almost got it 100% of the time saying, yes, that's the one. But it gets a little bit muddy when there's a very complex haptic interaction, like Railroad, where people are saying, oh, this actually feels like an explosion. But there's an interesting phenomenon that was happening, is that when people were doing gestures, they were more likely to get the correct haptic pattern after it. So including gestures into our final design is also a must, because that will make the correct human-computer interaction for the emotions.
After playtesting the haptic patterns, we started to brainstorm each of them with possible context and possible emotions. We also grouped them into 3 types of interactions in our experience, which is the main interaction, the background interaction, and the support interaction, which can help us shape our overall experience. And these are the 6 prototypes that we selected, that we think the pattern of it could be the main interaction in our experience. And in this phase, there's 2 main things that we're aimed to test. First, whether the haptic meets people's expectation, and second, whether they can trigger different emotions. So these are the first three prototypes that we created. And the first prototype is slapping the balloon, where you can slap the balloon paired with different sound effects. And the goal here is to explore how audio variation can shift the emotional tone of the same physical action, whether it's playful, neutral, or even surprising. For a second prototype, the interaction is simply pitching the little people paired with different text prompts on a wall. So the goal here is to explore how tactile actions combined with emotional cues can shift the feeling, whether it feels empathetic, curious, or even uncomfortable about picking up the little guy. So for the third prototype, you can hold the heart and feel the haptic pattern changing through the haptics. And pair with changing heartbeat pattern through the haptics. Yeah, the goal is to explore how rhythmic variation can shift the emotional tone of the interaction, making it feel calm or anxious or intense.
So once again, we went to Hunt Library and we did some tests also here in the ETC. We found 3 main things from the test, 1 for each prototype. One of the first things is that changing the context with the haptic is also a really good way to evoke emotion. We had players slapping the balloon, and then they would feel the slap of the balloon, but giving the player the ability to change the context using the button to a more playful sense, we saw that, and also from feedback from the playtesters that they became more playful when doing it. We also found out that in the pinching prototype, there was this kind of emotional connection of pinching this and feeling these little guys go. When you pinch them, they would scream, and then their body would become lifeless, and that really drove some emotion because you actually felt the little guy squirming, and then yeah. But anyways, we found that changing the context by saying, okay, this is your dad, this is a baby, this is a prisoner, people had a lot more empathy and not wanting to do anything if it was an emotional connection like a dad, a mom, or a baby. But if it was something like a prisoner, which is societally kind of looked down upon, they had no problem pinching that guy and killing them. But we also found that there was an emotional connection in the heartbeat prototype, because when you feel it, it increases in your hand and also decreases. And people felt in the survey that the increase was something like anxiety as well as energetic, while slowing down was something like, one person said, like feeling like a dead person's heart going down until they die, as well as calming. So with that, we're going to continue our playtest because we have 3 more prototypes. We tested them yesterday and had a playtest, but we also invite you this next week, Thursday and Friday, to come and test these other ones so that we can gain more valuable data for our final experience.
So with all of that playtesting and data gathered, we feel ready to move into the second half of our semester, which is designing our final experience. When we're choosing which of our prototypes might be promising for basing our final experience around, we're asking ourselves a couple of different questions. First is, what pattern are we choosing to focus on? How are we going to use it throughout the experience and reinforce it? How can we subvert it potentially, change its context to drive an emotional impact? And what kind of theming are we going to end up with by using this pattern? The reason why we're focusing on a single one of our prototypes as the focal point of designing our experience, even though we may end up using a bunch of different haptic patterns in the experience in the end, is that we really want to hone in on what makes one pattern an emotional experience so that we can reinforce it throughout the gameplay, so that the player feels it multiple times, and ultimately we want the climax of the emotional arc to be centered around that haptic experience. And here are some of our current ideas for what we want to move forward with in the semester. In our first idea here, you would play as a sailor on a salvage crew, pulling the ropes and feeling the tension of the ropes as you hauled up treasure from shipwrecked ships, and potentially even saving an overboard crewmate who may drown if you don't manage to pull them up. In the second one, you would play as a god creating a world, and you would feel the power of the elements as you blasted them around the landscape and created a world for your people. And in the third one, you would play as a reaper, moving around a scene and trying to find who is close to the end of their life, feeling their heartbeats, and choosing who you would want to shepherd over across the veil.
So with our final testing being done this week, we are going to finalize our experience by choosing one idea from the 3 that we currently have, and then work on the experience throughout the rest of the semester. Meanwhile, as we're working with a novel technology, we're keeping detailed research documentation throughout the process, including the initial exploration and the prototyping insights, and you can find everything on our website. We also aim to make our project to serve as the demo for any future haptics development needs. Thank you so much for listening. That's all we have.
I apologize if I missed this, but it seems like because it's a glove and the haptics aren't in the fingertips, that the really kind of fertile creative space would be in more grounded tactile experiences, things like touching real objects like a wall or picking up a hammer, versus this free-form exploration that you've been doing of free-form haptics in space.
So actually, in our second batch of prototyping, purely with the gloves and without the VR, we found that For simple interactions, yes, I think grounded ones are more easily recognizable and ambiguous, but for complex ones, a lot of times, without doing a specific action or being influenced by any context, they can, like, abstract feelings can be very easily accepted. There's a better way to say it.
Well, I will also say, so not having palm feeling is a limitation on like the complexity of things that we're able to do, but it's sort of a limitation in the same sense that we don't have force feedback on the gloves and we don't have temperature. There are a lot of things that we are trying to do with the fingertips and moving patterns around the fingertips and the wrist to try to get closer to that feeling as opposed to, because we can't directly do it. And especially when it comes to encouraging certain gestures in the gameplay, you can get a feeling in the palm if you have the player close their hand when you do the pattern. So a lot of it is dependent on how we're actually forming our gameplay around those patterns.
And also, like, really we're very random, it's not random actually, random patterns. When we found that when people aren't sure, they immediately start looking for fantastical interpretations. So we had like hand dissolving, blasting magic, and absorbing energy. And for the complicated patterns, there's a very, very high chance that they choose those as their accepted interpretation.
I have a question from chat. Carl would like to know, did you consider layering 2 gloves with a right and left glove on each hand? The opposite glove would be upside down, so it could provide haptics to the top of the fingers and palm of hand. Would that work?
It's okay, that's a complex question because these are pre-made things that we get from a manufacturer. And so we would have to dissect the glove and then have a sewing machine or something like that. But reversing it wouldn't be completely the right way based on how it actually is made because your hand does curl in and there's the back of it. So it would also be kind of out of scope.
The vHaptics SDK also considers each pair of, it expects you to only be using one pair of gloves. So it'll ask for the gloves sensor and there's no way to differentiate between the two. But we did consider early on the idea of, because we didn't have palm, we considered
tape a thing on
putting the gloves on backwards so that the back of the wrist sensor would be closer to the front of the palm. We didn't end up doing that because it means that all of the vibration motors are on your fingernails, which was not comfortable.
Question. So I appreciate the focus you had in sort of like identifying tactile patterns and how people understood them. And I'm kind of curious how you plan on maybe bringing a similar level of focus to your experimentation to disentangle emotions from what you're creating, recognizing that it's a much more complicated space to isolate variables.
Yeah. So one of the things that we found during our exploration is that we can't just innately just only play haptic patterns and be like emotion. We have to have certain context with it. We have to have some sort of scenario in it. And while the gameplay also has vibro-tactile, we hope that vibro-tactile, like pulling a rope and feeling the end of it dragging in the water, and then it releasing like somebody just released on man overboard, can drive our stuff.
I will also say that the haptics themselves don't create an emotion out of nothing. Most of what our emotional content is linked to sense memory. So when you have something, like in your life, you've experienced tension before, you've pulled on things in many different contexts, but overall those form sort of like an association with what the general feeling of tension or release or movement across the fingers are in a light or heavy pattern. Those things are linked to gestures or movements of the hand, and then those gestures are linked to emotions. The haptics serve to reinforce the gestures, make them strongly land in your mind, and then that leaps over into emotions. So in general, we're looking at haptics, what gestures they encourage, and then what emotions those gestures encourage. It's kind of like a two-step process. So they're closely linked, but they are separate in that if someone does the wrong gesture with the haptic pattern we intended, they will get a different emotion.
So you guys seem to not be afraid to allow the guests to have an uncomfortable experience. Grabbing a little guy's, that seems terrifying, grabbing a heart. Have you noticed that over time, like the longer I play something uncomfortable, does that change my engagement with it? Does that change my emotional response? And how can you use that to influence gameplay?
So we don't quite know that much because the playtesters were specifically only doing one prototype, which only has one interaction. But we did notice this from the playtesters, is that one of them decided to stop the experience as soon as it said, "your father." So we don't want to make an experience where, say, you have to play it out. We would probably want to do it in a sense to say, like, you can stop whatever you want. We didn't really know that it would have this big of an emotional response when doing it until we actually saw the testers doing it. So now we know for the future, but yeah.
One of the reasons we chose to have uncomfortable experiences for our testing is because it's clear enough for us to test. But also, for our final experience, what we want to do is using the identified emotion and storyline climax, we pay attention to really have to reinforce doing that action and having that feedback so that it becomes a sensed memory for the players to really get to that climax.
So I just want to share, one of our playtesters test one of our uncomfortable experience, which is you have to touch a goo. And we also ran a A/B test on that. So we turn on and off the haptic. The playtester says, oh, she wants to play with the goo more when she have the haptic because it's interesting. Like you touch something and you really feel something and you want to try it again. It just, although it's uncomfortable, but it makes the experience different when they have haptics.
Yeah, and one final thing is one of our playtesters, we intended our target audience to be people who are not VR naive guests. So, but one of our Hunt Library playtests, we did have a completely naive guest of VR experience, and she did not at all talk about any sensation being too much from our experience. She said it was all part of the experience, and it really just it's good.